if every element of the set A has one and only one image in the set B, and it is denoted as F from A to B. The two ordered pairs 2, 2 and 2, 4 will have the same first element as 2. Therefore, this is not a function. According to the definition, there should be a unique association. Here there are two associations, 2 to 2 and 2 to 4. Therefore, this is not a function. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. So in my previous class, we have discussed regarding relations and types of relations and the problems based on types of relation, equivalence relation. Now in this session, I am going to discuss the next concept, very important concept called the functions. Relations and functions. The first part is the relation, second part is the function. Now, let us know regarding the definition of a function and different types of functions. So, you may expect 5 marks questions or 7 marks question, definition of a function and different types of functions and the problems based on that. Now, let us come to a function. What is the definition of a function? Functions and types of function. Let us know regarding the definition of a function. So, a relation, first of all, it is a relation F from A to B, from a set A to set B is said to be a function. A relation F, first of all, it is a relation F from A to B is said to be a function if every element of the set A has one and only one image in the set B, and it is denoted as F from A to B. So, here this is called a relation. F from A to B is called as a function. F from A to B is a function. The set of all elements, if F from A to B is a function, the set of all first elements of the function is called the domain, and the set of all second elements of the function is called as the codomain. So, here this is called as the domain and this is codomain, and this A, this pre-image of B, A is the pre-image of B under F, whereas this B is called the image of A under F. This B is called the image of A under F and A is called the pre-image of B under F. So, a function is nothing but it is a mapping. A function is a mapping from every element of set A to B, set B. If F from A to B is a function, is denoted as F from A to B is a function where A, the set of all first elements of the function is called the domain and the set of all second elements of the function is called as the codomain. Let us take for example, let me explain with an example. Now, let us consider a set. Consider a set A is equal to 1, 2 and 3. Another set B is equal to A, B, C. Right. Let a relation is defined by F is equal to 1, A, then 2, C and 3, B. Now, this is the relation, a function. Let us check whether it is a function or not. Represent this in a diagram, arrow diagram. This is A and B. What is A contains? 1, 2 and 3. What is B contains? A, B, C. What is the mapping given? 1 to A, 1 to A, map this, 1 to A. Next, 2 to C, 2 to C and again 3 to B. So, therefore, F from A to B, F from A to B is a function. So, here different elements of A have different images. That is, the set A and set B is said to be a function if every element of set A has a unique image in set B. Every element of set A has one and only one, that is unique image in set B. That is it. So, F from A to B is called a function. Now, let me take one more example. Let us write one more example. If A and B, this is A and B. So, let us consider A contains 2, 3 and 4, B contains 2 and 4. Now, let us map 2 to 2, 2 to 4, 3 to 4, right, and again 4 to 4. See here, how to write here, the function F is equal to 2, 2, then again 2, 4, again 3, 4 and again 4, 4. So, here the element 2 is associated with two different images. So, here the element 2 of the set A is associated with two elements 2 and 4. So therefore this is not a function. F from A to B is not a function. That means here the two ordered pairs 2 comma 2 and 2 comma 4 will have the same first element. The two ordered pairs 2 comma 2 and 2 comma 4 will have the same first element as 2. Therefore this is not a function. So according to definition, a set has one and only one image in set B. This 2 has two images in set B. Therefore this is not a function. Now by knowing this, let us know regarding different types of functions. Now let us take an example. So before that, if f is a function from A to B and if A comma B belongs to F, then f of A is equal to phi function of A is equal to B means this B is called the image of A under F. This B is the image of A. B is the image of A under the function and is called as the pre-image of B under F. Here this A is called the pre-image, B is called the image and A is called the pre-image of F under the function. Let us take an example. If A is equal to 2, 3, 4 and B is equal to 1, 2, if mapping is given, F from A to B is mapped 2 to 1, 2 to 1, 3 to 1 and 4 to 2. So here F from A to B is a function and this 2, 3, 4 is called the domain, has the unique image. The domain of this has unique images, that is 1, 2. So the set A is called the domain and this is called as the codomain. Yeah, this domain of the function, that is the elements 2, 3 and 4 has unique images 1 and 2. Now let us take this example. If A is equal to 2, 3, 4, B is equal to 2, 3, 4, let us map 2 to 2, 2 to 3 and 2 to 2, 2 to 4, again 3 to 3 and 4 to 4. Here what is the function? Here the ordered pairs are 2, 2, 2, 4, again then 3, 3 and again 4, 4. Now what is say? The element 2, 2 and 2, 4, these two ordered pair will have the same first element as 2. Therefore, this is not a function. 2 belongs to 2 and 4, two different images 2 and 4. So there are two different images for the element 2. Therefore, this is not a function. According to the definition, there should be a unique association. Here there are two associations 2 to 2 and 2 to 4. Therefore, this is not a function. F from A to B is not a function. Now clearly you got an idea regarding a function. By knowing this, let us know regarding the types of function. What are the types of functions? So there are different types of function in which let us know regarding the first one, 1 function, or it is also called as a injective function. 1 function, or it is also called as an injective function. When did we say a function is 1, if there is a 1-to-1 mapping, that is a function f from x comma y is defined to be 1 or injective function if the images of distinct elements of x and y are distinct. If images of distinct elements of x and y are distinct elements of x will have distinct images of y, then f from x comma y is said to be an 1 function. That is, if for all x1 comma x2 belongs to x, if x1 comma x2 belongs to x, then f of x1 is equal to f of x2 implies x1 is equal to x2, then such a function is called an 1 function, or it is also called as a injective function. So a function f from x to y is said to be a 1 function if different elements of the set x will have the different images in the set y. F from A to B is said to be a 1 function if different elements of the set A will have the different images in the set B, then it is called an 1 function. There is a unique association, 1-to-1 association. Now let us take an example. This is an example for 1 function. So A contains 1, 2, 3, 4, B contains A, B, C, D, the mapping. So 1 to A, 1 to B, 2 to A, 3 to C and 4 to D. So here there is 1-to-1 association. That is, f of this function is given by f is equal to 1 comma B, 1 to B, again 2 to A, again 3 to C and 4 to D. So here all the elements of A has unique association. So therefore this is a 1 1 function, that is every element of the set A has distinct images in set B. Now let us come to this function. Here A 1 2 3 4 A B C D E and F. So the mapping is 1 to A, 1 comma A, again 2 comma B, 2 to B, 3 to F and 4 to D, 4 comma D. Here also all the elements of A will have the distinct images in set B, therefore F from A to B is 1 1 function. Okay. So the symbolic way of representing this 1 1 function is, if for every x1 comma x2 belongs to x, f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is said to be an 1 1 function. Now in the examination they may ask like this: if f from, for example, let us take an example, if f from R to R is defined by f of x is equal to 4x plus 3, show that f is 1 1 function. Now to verify this as 1 1 function, let us take this statement: for all x1 comma x2, for all x1 comma x2 belongs to R, f of x1 is equal to f of x2. f of x1 is equal to f of x2 implies, what is f of x1? f of x is given to be 4x plus 3. f of x1 can be written as 4x1 plus 3 is equal to f of x2 is 4x plus 3. Transfer plus 3 to the right hand side, plus 3 and minus 3 gets cancelled. We will get 4x1 is equal to 4x2. Divide by 4, 4 and 4 gets cancelled, x1 is equal to x2. So f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore f of x is a 1 1 function. So we can write f of x is 1 1 function. That's it. See here. So what is to prove? To prove that f of x is 1 1 function, let us consider for all x1 comma x2 belongs to the set R, f of x1 is equal to f of x2 implies 4x1 plus 3 is equal to 4x2 plus 3, plus 3 and minus 3 gets cancelled if we transfer plus 3 to the right hand side, and 4x1 is equal to 4x2, divide by 4, x1 is equal to x2. That is, this condition is satisfied. f of x1 is equal to f of x2 implies x1 is equal to x2, therefore f of x is 1 1 function. Now let us come to the next type of function. Next, the second one is an onto function, or it is also called as a surjective function. Onto function or a surjective function. So a function f from x to y is said to be an onto or a surjective function if every element of y is the image of some element of x. That means all the elements of B must be used. If every element of y, every element of the second set, every element of y must be an image of some element of x under f. That is, for every y belongs to y, there exists an element x in x such that f of x is equal to y. Very important condition. That is, a function f from x to y is said to be an onto function or surjective function if every element of y is an image of some element of x under f. That is, for every element y belongs to y, there exists an element x in x such that f of x is equal to y. Now let us take an example. If a is equal to 1, 2, 3, 4 and the mapping 1 to a, 2 to b, 3 to c and 4 to d. Here all the elements of B have the images. So f from a to b is called an onto function. f of 1 is a, f of 2 is a, f of 3 is c and f of 4 is also equal to b. So therefore f from a to b is a function, that is, for every y belongs to y, there exists an element x such that f of x is equal to y. Function of x is equal. So function of 1 is a, function of 2 is a, function of 3 is c, function of 4 is equal to b. So that is f of x is equal to y. So let me take one more example. If a is equal to 1, 2, 3, 4, b is equal to a, b, c, d, f from a to b is an onto function. That is, function of 1 is d, function of 2 is b, function of 3 is a, function of 4 is c. So that means every element of y will have an image for every element of b. For every element of b, there exists an element in a such that f of x is equal to y, f of a is equal to f of 1 is equal to d, f of 2 is equal to b, f of 3 is equal to a and f of 4. So such type of functions is called an onto function. So that is, for every y belongs to y, there exists an element x in x such that f of x is equal to y. Such function is called an onto function. That means every element of y is an image of this element. Every element of y must be an image of some element x under f. That's it. That means all the elements of B must be used. Now let us take an example statement. If f from R to R is defined by, if f from R to R is defined by the same problem, f of x is equal to 4x plus 3, show that f of x is an onto function. Now how to verify this? Now according to the definition, for every y belongs to y, there exists x in x. For every y belongs to y, there exists an element f of x is equal to y. There exists an x in x such that f of x is equal to y. Right. There exists an x in y, x such that there exists x belongs to x such that f of x is equal to y. Now what is f of x? F of x is 4x plus 3 is equal to y. So 4x is equal to y minus 3, x is equal to y minus 3 by 4 belongs to R. Now such that f of this y minus 3 by 4, such that this f of y minus 3 by 4 is equal to, substitute the value of x as y minus 3, 4 times y minus 3 by 4 plus 3, this 4 gets cancelled, you have y minus 3 plus 3 minus 3 gets cancelled, y belongs to R. So f of x is equal to y. This is nothing but f of x. F of x is equal to y. This condition is satisfied. So therefore f of x is called an onto function. This is called an onto function. That's it. Right. See, for all y belongs to y, there exists an x such that f of x is equal to y. So what is f of x? F of x is nothing but 4x plus 3 is equal to y. Get the value of x from this. 4x is equal to y minus 3, or x is equal to y minus 3 by 4 belongs to R, such that f of x, what is f of x? 4 times x is nothing but y minus 3 by 4 plus 3, 4 and 4 gets cancelled, minus 3 plus 3 gets cancelled, that's equal to y. F of x is equal to y belongs to R, hence f of x is an onto function. This is how we are going to verify 1, 1 and onto function. Now let us come to the next one. Suppose if a function is both 1, 1 and onto, then what it is called? So such a function is called a bijective function. A function which is both 1, 1 and onto, then such a function is called an bijective function. A function f from x to y is said to be a bijective function if f is both 1, 1 and onto function. So if a function is both 1, 1 and onto, such a function is called a bijective function. Now let us take an example. If a is equal to 1, 2, 3, 4, b is equal to a, b, c, d, then f from a to b is both 1, 1 and onto function. So let us map 1 to d, again 2 to a, 3 to b and 4 to c. So there is 1 to 1 mapping, as well as all the elements of b have the images. So therefore this is an example for a bijective function, which is both, the function is both 1, 1 as well as onto function. So therefore this is a bijective function. So a function which is both 1, 1 and onto is called as a bijective function. Very important definition. Let us take a problem based on this 1, 1 function, onto function and a bijective function. Now show that the function f from n to n given by f of x is equal to 2x is 1, 1 but not onto function. Now what is to verify? So 1, 1, for verification of 1, 1 function, f of x1 is equal to f of x2 implies x1 is equal to x2. So verify first whether this condition is satisfied or not. Then go for the second function. For all y belongs to y, there exists an element x in x such that f of x is equal to y. If this condition is satisfied, then it is called an onto function. Now let us verify this. Now first, given f of x is equal to 2x in n. So for every x1 comma x2 belongs to n, then f of x1 is equal to f of x2. That is, f of x is equal to 2x. for every x1 and x2 belongs to n, f of x1 can be written as 2 times x1 and f of x2 can be written as 2 times x2. Now, f of x1 is equal to f of x2 implies 2x1 is equal to 2x2, 2 and 2 gets cancelled, x1 is equal to x2. That means f of x1 is equal to f of x2 implies x1 is equal to x2. So, f of x1 is equal to f of x2 implies x1 is equal to x2. x1 is equal to x2 means f of x is 1, 1 function. So, therefore, f of x is 1, 1 function. Given f of x is equal to 2x in n, for all x1 comma x2 belongs to n, f of x1 is equal to 2x1, f of x2 is equal to 2x2. What is the definition? F of x1 is equal to f of x2 implies 2x1 is equal to 2x2, 2 and 2 gets cancelled, x1 is equal to x2. That is, if f of x1 is equal to f of x2 implies x1 is equal to x2, therefore, f of x is a 1, 1 function. Now, to verify f of x is an onto function, f is not an onto function. As 1 belongs to n, there does not exist any element in n such that f of x is equal to 2x is equal to 1. So, if f of x is equal to 2x, if 2x is equal to 1 means x is equal to 1 by 2. So, there does not exist any element such that f of x is equal to 2x, which is always equal to 1. So, therefore, f of x is not an onto function. That is, f is not an onto function. As 1 belongs to a natural number, there does not exist any natural number such that 2 times x is always equal to 1. 2x is equal to 1. Okay. Now, let us take another example. What is example 2? Show that the function f from R to R is defined by f of x is equal to x square is neither 1, 1 nor onto function. So, here f from R to R is nothing but the set of real numbers to real numbers, is neither 1, 1 function or not onto function. Let us take for example, so according to the definition, if x1 is equal to x2 implies f of x1 is equal to f of x2, or if x1 is not equal to x2 implies f of x1 is also not equal to f of x2. Let us take an example. If x1 is equal to 1 and x2 is equal to minus 1, here x1 is not equal to x2, then what implies f of x1 is also not equal to f of x2, then it is called 1, 1 function. What is f of x1? F of x1, f of x is defined to be x square. So, f of 1, 1. So, function of 1 is nothing but 1 square is equal to 1. What is f of x2? F of x2, f of minus 1. Minus 1 is nothing but minus 1 square is also equal. So, if x1 is not equal to x2, f of x1 is equal to f of x2. So, therefore, we can say f of x is not 1, 1 function. See, here this is plus 1 and minus 1. This is plus 1. So, this is f of 1 function. F of 1 is equal to f of 1 is plus 1, f of minus is also plus 1. So, since x1 is not equal to x2, but f of x1 is equal to f of x2, therefore, this is not a 1, 1 function. Now, let me explain here. So, if x1 is equal to minus 1 and x2 is equal to 1, since x1 is not equal to x2, f of x1 is equal to minus 1 is minus 1 square is plus 1, f of x2, f of plus 1, 1 square is 1. So, when x1 is not equal to x2, f of x1 is equal to f of x2. So, here this is plus 1 and minus 1, this is plus 1. When for these both values we have plus 1. So, therefore, f is not a 1, 1 function. Now, on the other hand, let us verify whether it is an onto or not. Let f of x is equal to y. What is f of x? X square. Since f of x is equal to x square, so x is equal to root y. So, does not belongs to real number. Suppose if you put y is equal to minus, then the element minus 2 is the codomain R is not an image of y. That is the element in the domain R. So, therefore, f is not an onto function. So, if x square is equal to y, then y is equal to root of y does not belongs to R. So, that is suppose if you put y is equal to minus 2, the element minus 2 in the codomain R is not image of any element in the domain R. So, therefore, this R is not an onto function. So therefore, f of x is neither 1 function nor onto function. That is, if f of x is equal to x square, from the set f from R to R is neither 1 function nor an onto function. This is not a bijective function. So these are the few problems based on 1 function and onto function. So hope you got an idea regarding a function and the type of functions and how to solve 1 function and how to verify 1 and onto function. So that's all regarding today's sessions. Hope you followed. Let us meet with different concepts in the next session. Thank you. Thank you very much.